Times gesture and hello to participants of KLISEE 2022. Let us wrap up the year by imagining um, people and nature empowerment through analytics, the road to an unceasing breath of sustainability. I am Arniza Ghazali, academic staff of University Sains Penang, and my co-author Associate Professor Dr. Masin from also University of Life Sciences are sharing deliberation made on analytics to generate sustainability aligned recommendation. As laid in the abstract, the focus of this session will be on the management of biomass generated from the region's agro commodity, palm oil, and rubber products. For that, we will first define biomass and take a glimpse at the rubber plantation residue, sustainable use, and the reason for its sustainability. Next is oil palm residue, particularly EFB and its uses. This should lead us to the problem statement and define the aim of the study, approach to accomplish data and formulate solutions will be shared, and presentation will wrap up with the significance of the deliberation. So to make sure that we are on the same page, let us agree that biomass refer to the physics of living things, quantifiable as ash mass, organic mass, and dry mass. Biomass can be of plant origin, animal droppings, geological structure, viruses, microbes, their derivatives in the form of threads, clothes, or silk. And this study focuses on plant leftovers from meals and plantation. Alright, that said, the biomass in focus are the top agro commodity, oil residues and felled rubber wood from a rubber plantation, which all first for contributing immensely to the prosperity not limited to Malaysia. The views of the oil palm and rubber estates, the major reasons for the country's top 5 listing in the export landscape. Along with the money are the bulky residues, the empty fruit plant from the oil milling activities, and rubber wood at its post latex producing years. Palm milling products are projected to increase tremendously in the nearest future due to an added competing production of sugar from palm fruits. Also hot selling is palm milk. Also, a recent discovery that expands the demand for palm oil. Palm oil. Okay, all these plan for established circularity with rubber estates taking the lead. Right. Terminology-wise, circularity used interchangeably with the term circular bioeconomy or CBE in short is about resource efficient management, aiming at lowering the emission, particularly the heat trapping carbon dioxide and the corrosive methane. Circularity can also be achieved by delaying a product's end of life via reuse and repurpose, and at a commercial scale, products are rerouted to other factories, allowing industrial symbiosis to take place. As a way of reducing resource demand, mulching and composting are ways of completing the nutrient cycle by soil mineralization and carbon and phosphate sequestration. Um, it is the cycle that makes zero waste possible, and hence circularity or circular economy. The initiative is set for humankind and nature to coexist peacefully, which is the heart of sustainability. One way of checking for circular resource management is by constructing the biomass circularity science model, BCS, like shown in the on the slide. Okay, this helps to identify waste points and reroute the waste to a process or a market. In the former case, the commodity acts as a feedstock of a process instead of landing at the dump site. Primary harvest loop 1, refers to the plantation waste routed to the left loop as they are the byproducts of the primary harvest, while ABC are the direct derivative of the primary harvest. DEF are the products made from the primary derivatives. On the left loop, commodity is not limited to commodities not limited to GHI, can be used to produce product JKL, just to name a few. The looping, rerouting, and reconceptualizing waste as commodity, for instance GHI, all aims at realizing sustainability. That said, however, sustainability is often loosely associated with waste utilization, product biodegradability. The deeper meaning of sustainability embedded in the life cycle assessment and certified by ISO 14040, International Standard Organization, remain disconnected to the feasibility studies due to the highly technical, ensuing cost and the time-consuming process. Although LCA life cycle assessment used in the ISO 14040 sets the tone for objectivity, the bias contained in the data input process can be detrimental, leading to commercial project closure or valley of death projects, VOD, as indicated on the slide. All right, that said, to troubleshoot the issue, this study demonstrates the use of BCS, Biomass Circularity Science Model, to identify waste and points of discharge for its generation. Next, each commodity is mapped to a product and detailed with the processing steps to assess complexity, done with FPP or feedstock process product framework. To overcome the one-track nature of assumption for sustainability, this study lays the diagrammatic form of analytics for insight into the auto-generated recommendation and the measurable sustainability criteria data that can be fixed with AI capable of triangulation. Triangulation is the reason for proposing analytics. Big data analytics (BDA) is typically used in the manufacturing, telecommunication, health, stock market, and fintech, and is still new to agro sector. Triangulation involves analyzing the database of results, taking into account three factors simultaneously, according to Nightingale and Noble and Hill. And complementary triangulation is adopted to understand the relationship between a process, product, and how they affect operational costs, formulate the visual representation of an analytic derived sustainability assessment. By establishing the map of process and products with correctional processes for responsible management, we could decide on the feed data for the comprehensive analytics and the scientific details that our data scientists should develop for the biomass management decisions. To demonstrate analytics acumen, the processes involved in the scientific literature analysis were performed manually. Literature on circular bioeconomy, global rubber sector, previous works on EFB utilization, and a long data acquisition journey through indirect interaction with commercial project insiders took place. The literature aided in gathering sufficient information to develop the DCS, Biomass Circularity Science Model, and the FPP or Feedstock Process Product Framework for the coverage in this study. Current progress, therefore, shows BCS demonstrates the higher level of biomass variety types. Okay, here. And compositional complexity coming from the all palm plantation and milling. These are in contrast to rubber wood, and thus the processing complexity needs to be expected. Noteworthy is that even attempts to isolate the predominant component can be a billion-dollar gamble. Deliberation reveals that at least three commercial projects involving pulp extraction from EFB ended up as a loss. So to fix the challenges, the FPP framework of EFB was created to assess process and cost. These are some of the literature used to construct the framework for EFB. Alright, and this is the form of fruit bunch biomass, starting with the fresh fruit bunch on the left to empty fruit bunch ash on the right, on the far right. So the easy physical process, low cost process normally involves open burning, happily adopted by farmers because it is almost capital free, but it taxes the environment and human health. Alright, it leaves an amount of emission in the form of pollutants, particulate matter, carbon dioxide, carbon monoxide. Alright, and that can actually be fixed with a closed system using pollutant absorber. EFB can also be used in biochemical reactions to produce vermicompost. Add worm and we can get biochemical reactions in worm's digestive system to produce high quality compost. Alternatively, reaction with microorganisms can also produce compost. Of course, not without emission of methane. This methane can be captured and rerouted for kitchen use or building use. Another form of commodity, in other words. The EFB can also be turned into compost by the high-tech environmental recovery system. It is a system with bacterial formulation hidden in the chamber, and the reaction goes for quite some time. Of course, also with emission and EFB next can be pelletized, okay, to produce bioenergy. The easy processes not involving chemical is also offered by geotextile production or fiber mat production, and direct fortification of EAB allows it to be used as permanent feed, while the more complex chemical processes can produce many interesting things but involves a lot of cleaning and processes, water intensive process, get various forms of pulp. There are simple, short, fast, rapid process, and there are also long and very corrosive process like this. Okay, but in the end, the pulp quality is high in terms of cellulose purity, but such a process would require a resource recovery system, which is another capital to consider, right? But from the cellulose, processing can be proceeded to produce cellulose, CMC, bioplastics, and there are various ways from pulp of from EFB. We can also extract sugar, carry out fermentation to get ethanol or biofuel. Okay, the next use is EFB ash, fertilizer, as cementing agent, lightweight bricks, road construction, and many more. These can be used to resolve issues like pollutants from open burning or any form of combustion to produce fertilizer. In actual fact, cost-wise, we can see the higher capital is involved in processing of EFB involving chemicals and corrosive uh, uh, conditions, high pressure, high chemical concentration. Okay, while processes involving chemicals may require the highest capital, other factors resulting in factory closure or dead ends are now understood. Um, the coiling of the string in this area, okay, starting from here, it coils to the left. To fit the landscape layout hides the process extensiveness or process length that manifests complexity. So when we unbundle the process to visualize, we can compare. On the left is EFB conversion to bioethanol, involving something like $1 trillion capital investment, while on the right is EFB conversion to briquettes. Process is a lot simpler and rapid. So why briquette? Briquette, as the sand has been tracked today, briquette production involves low capital, low risk, and the demand is high now, timeliness because of efforts to reduce emission, circular bioeconomy, and bioethanol as an alternative fuel to complement fossil fuel. Now imagine big data analytics marking the measurable sustainability criteria and accumulating values. Efficient evaluation can be executed, it seems, to reach a sound decision. Yeah, imagine a system generating CF, carbon footprint and ecological footprint, water footprint along the process that we propose. At a glance, comparable sizes of the FPP uh, frameworks for the existing multi-billion-dollar rubber wood utilization to the FPP size for briquette production shed light on the potential huge profit from briquette production. Unified use, simple, low-risk processes, and market demand were identified as key for sustainability. In a sense, BCS, the biomass circularity science model, and the FPP as visualization tools provide a logical impression of process complexity and thus the underpinning risk. Analytics, with its capacity for triangulation, is imaginably needed as the FPP framework grows beyond human cognitive capacity. Larger variety of biomass commodity and thus compositional and processing complexity of the oil palm biomass mixed feedstock used in a simple low-risk process for production of product in demand would be the way to model the size of rubber wood management captured in the rubber wood FPP framework. As the FPP grows, the evaluation of sustainability and risk may be out of hand. Thus, availing the imagined analytics is envisioned as the way forward for humankind and nature to coexist harmoniously while pursuing industrialization. This project is sponsored by the Ministry of Higher Education through FRGS and Research University Grant Scheme supporting the Sustainable Development Goal 12, Responsible Consumption and Production. All, thank you for availing yourself to this session. Have a prosperous 2023. Assalamualaikum warahmatullahi wabarakatuh.